All right, similar figures. So triangle sum theory we talked about in class. That is where the 180 degrees is equal to the sum of all of the angles inside the triangle. So no matter what those angles are, when you add them up, they equal 180 degrees. Now remember, we also talked about what it means to be congruent. Now we talked about that in terms of angles, but you can also be congruent with a shape. So if I take this shape here, I can rotate it and it will make this shape here. That also means that this guy here, this is congruent to this guy. All I have to do is flip him over. Now for angles, what did we say? Well, if it is congruent, that means that they're going to be equal. So if this angle A is equal to this angle B, then those two angles are congruent. Now, the angle-angle similarity postulate, this one is a little bit new. We didn't do this yesterday. If two angles of one triangle are congruent to two angles of another triangle, then the triangles are similar. So, if this angle is congruent to this angle and this angle is congruent to this angle, then these two angles must be similar. All right, so then now look at these two. Are these two triangles similar? So we have two right triangles, and we have here, just to make sure you can see, we have this guy is 60 degrees and this guy is 30 degrees. So are they similar? Well, you know that these guys are congruent, but I don't know if these guys are not congruent. So the only way you can figure out if they're similar is you must first find the third angle here. How do I do that? Well, 90 plus 60, and then I need to take that away from 180. So what would that be? What is 180 minus 60 minus 30? All right, then once you get that, if this angle here is 30, then this angle would be congruent to this one, and this one would be congruent to that. So if the angles are equal, they're congruent. If they're not equal, they're not congruent. So go ahead and try that. Now, proportional sides. So what if you don't know the angles? There's another way to tell if two triangles are similar. We're going to look at the ratios. Here we are, still working with those ratios of the two sides. So if I have these two triangles, this one is side 1, side 2, side 3. The other triangle is 2, 4, and 6. So if I look at the ratio of two sides, if they're equal, they're similar. So we look here, is 1 to 2, right here, 1 over 2, is that equal to the same sides on the other triangle, 2 over 4? Is 1 over 2 equal to 2 over 4? Of course it is. And so therefore, these two triangles are similar. So if the ratios are equal, the triangles are similar. So I want you to go ahead and I want you to try these. This one, I want you to use those side, the proportional sides, and these I want you to use the angles to determine if they are similar. Go ahead and pause the thing and try to answer that. Now, we have transversals, lines that cross. So we talked about our lines that go like this are parallel. They never cross each other. Lines that cross, they are transverse. Okay? So our practice number 1 on page 154 asks, are the triangles ABC and the triangles DEC, are they similar? So here's ABC, here's DEC. Are these two triangles similar? Well, when the lines cross, those angles that they make are equal. Remember, we talked about this in class. The angle here and the angle there would be equal, or would be congruent angles. So the angle ACB, there's our angle symbol, is equal to the angle ECD. And the angle BAC is going to be equal to the angle EDC because they are congruent. Therefore, the triangle ABC and the triangle DEC are going to be, in fact, similar. All right, practice 2. You can also have similar triangles with one of them inside the other. So here's a big triangle, and inside it is drawn a smaller triangle. Now I could redraw that with the big triangle here on this side and the small triangle just flipped out to the other way. This is how we did it for our lab. Now it is the distance for the shadow is 23.5 feet. The distance for the person is 7.5 feet. So you can leave it drawn this way, or you can redraw it this way. But we're going to use that same ratio we did in the gym. Little a over big A is equal to big A over big B. So our numbers, little a is 5.5, little b is 7.5, big B is 23.5. So we can figure out the height by solving that cross, multiply, and divide to get our 17.2 feet. For practice 3, we have a couple of triangles. This one, our LMN and our QRS triangle. Now, if I want to know what x is here, and I am told that these two guys are similar, then I know that the ratio of their sides, 30 to 75, is going to be equal of the ratio of x plus 5 to 50. So now I've got 30 over 75 equal to x plus 5 over 50 because they're similar triangles. I need to get 50 out of the bottom, so I multiply both sides by 50. That crosses off my 50. So when I do this, I get this is equal to 20. 20 is equal to x plus 5. If I want to get x by itself, I subtract 5 from both sides, leading me to determine that x is equal to 15. And, oh, you don't need that part. So, all right, we'll see you when I get back.